In today's lesson, we are going to be looking at the quadratic formula. So this is our last lesson of this unit, where we're looking at kind of solving equations using quadratics. And the quadratic formula is an important formula that you will be using because it is a helpful way to kind of solve or find solutions when we can't use some of the other methods. So the first thing we want to do, we have three quadratics here. We have A, B, and C. We just want to know how many roots are there in each of them. Remember, roots are just another term for our x-intercepts. So if I look at A, there are two roots, 1 and 2. So for A, there are two roots. For B, there is one root. And for C, it doesn't touch the x-axis at all, so there are 0 roots. So these are the three kind of scenarios that we could come up with, or we could have, depending on what quadratic we have, or depending on what we're modeling, or depending on the equation. And so it's just the idea that there could be three different possible scenarios. Right? We have two intercepts, we have 1, or we have 0. Or you could think we have two solutions, we have 1, or we have 0. And that's what we're going to be using or looking for when we're dealing with the quadratic formula. So the quadratic formula determines the roots of a quadratic equation in the form ax squared plus bx plus c. So again, remember, this is standard form. So this is when we're given standard form. Now this formula that we see below is ideal when the quadratic equation cannot be factored easily. Right? So if we can't factor a quadratic equation, or if we can't factor it in standard form to find our roots, we can use the quadratic formula or the quadratic equation. Right? Now, even if it can be factored, you can still use this formula. Factoring just tends to be a little bit quicker, but this formula works regardless of whether it can be factored or not. So the formula is x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And all of these values, this b comes from our standard form. So our b comes from our standard form, our a comes from our standard form, and our c also comes from our standard form. So everything here comes from our standard form, and these are going to give us our roots. Now, how many possible solutions can this formula give us? Right? Well, we might look at and say, well, it's just x equals, so it's only going to give us 1. However, this will give us two solutions. Or we could say 0, 1, or 2 solutions. It all depends on what value we have under here, under this square root. Because depending on that, we might end up square rooting a negative, which won't happen. We might square root a 0, which means they're not going to have anything. It's not going to be anything different. Or we might square root a positive number where we might get two possible values. You might be thinking, how do I get two possible values from this? Well, remember when we take the square root of a number, right? So for example, if I take the square root of 9, normally we'd say, okay, our calculator says that's 3. However, there is another possible solution. We could have also negative 3. So really, the answer to the square root of a number, so if I say the square root, do the same thing, square root of 9, it's plus or minus 3. So we actually get two values or two solutions to this question. And in our equation, we can see we have, let me use a different color, this plus minus, right? This plus minus gives us two possible solutions. Because it's going to be negative b plus the square root of this number divided by 2a, and negative b minus the square root of this number divided by 2a. So we're going to have two possible solutions. Right? We're going to have addition and we're going to have a subtraction. Right? And we'll look at that when we go through our examples. So we just want to go through, use the quadratic equation to solve each of the following for its x-intercepts. So I have my standard form. I have my a, my b, and my c value. If it helps, you can write it off to the side as well. So a equals, because I don't see anything, there's an invisible 1. B equals positive 2, and C equals 5. You do have to be careful to make sure that you include the sign in front when you're entering it into our formula, or the quadratic formula. So we have x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So all I'm going to do is just sub in the values that I found. So negative b, so it becomes negative 2 plus or minus the square root of 2 squared. Let me bring this down a bit. Get some separation. Minus 2, or square root of 2 squared minus 4 times 1 times 5. And this is all going to be divided by 2 times 1. So let's continue to go through. I'm going to simplify in underneath the square root first. So it's going to be negative 2, because that negative comes from the formula. It does say negative b. Make sure you are including all the signs that are necessary. So take your time. Try not to rush it. Make sure your layout is neat, right? Because just by having a different sign can change your answer. So negative b, or for negative 2 plus or minus the square root of 2 squared, which is 4, minus 4 times 5, 1 times 5, which is 20. So I get, and then divided by 2. I can continue through and simplify. I get negative 2 plus or minus the square root of negative 16 divided by 2. Now, in this case, we would go through and we could split it up into 2 parts. Negative 2 plus the square root of negative 16 divided by 2, and negative 2 minus the square root of negative 16 divided by 2. However, right, so, sorry, jumping all over the place. This is where we would see the 2 possible solutions. It's x equals all the way down, and now we split it off into 2 parts. X equals plus negative 2 plus, and x equals negative 2 minus. However, one thing to note, if I go back and look at this square root, I am trying to square root a negative. Can we square root a negative value? We cannot. So we can't square root a negative. So there are no solutions. Right? There is no solution. So if we had a negative under there, we get no solutions. So that means if we tried to type this on a calculator, you would get x equals error for both of them. So therefore, there are no x-intercepts. No x-intercepts or no roots. There are no solutions to this quadratic. Doesn't mean it doesn't exist. It just means it doesn't touch the x-axis. Next example, same idea. We're going to go through, we're going to find our A, B, and C. A, B, and C. Right, so A is equal to 3, B is equal to 8, and C is equal to 3. Again, making sure that we have our signs, we want to make sure that any signs in our equation are carried over when we plug it in. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Now you don't have to memorize this formula, but as you go over it, as you practice this, it might become kind of secondhand. But again, you don't need to memorize this, but you do need to understand how to calculate, right, and calculate your values. So you do want to make sure that you are going through following BEDMAS, right? Doing everything under the square root first. Make sure you're being neat including all the signs that are necessary, not forgetting any signs or skipping over it. So negative b means negative 8 plus or minus the square root of 8 squared minus 4 times 3 times 3, all divided by 2 times 3. Don't forget that division part at the end. For some reason, sometimes students like to forget that divide by 2a. X equals negative 8 plus or minus. I'm going to simplify underneath this square root. So 8 squared is 64 minus 4 times 3 or 36 divided by 6. Now you might be able to then simplify the entire square root thing first. 64 minus 36 and then square rooted. You could enter this entire thing into your calculator if you wanted to and just go right to an answer. I would still suggest you do need to still show me, if you were to go through, you need to show me this step, and then I'll show you the next one that you should have to show. Right? So we can simplify this even further. X equals negative 8 plus or minus the square root of 28 divided by 6. I would suggest, I do want to see this value just so I can see, or this step as well. So you could start off with the equation, show this first step where you plugged everything in, show this simplified step down here. Now we're going to split it up into two. We're going to simplify it a little bit more, but I do want to see what you get under the square root, so if I'm giving part marks, I can say, okay, yes, they figured that out, then there's just a wrong calculation later on. If we take the square root of 28, it doesn't work out nice, which is okay, but we get 5.292 divided by 6. And again, here's now where we're going to split it off into two parts. Actually, let me just see if I can move this up a little bit just for space. I'm going to split it up into two parts. X equals negative 8 plus 5.292 divided by 6, and x equals negative 8 minus 5.292, all divided by 6. If I go through and simplify, I get x equals negative 0.45, and x is equal to negative 2.22. So again, if you're showing things, I would need to see all of this. So basically every kind of line that we see down here, that's what you would need to show. So there's only really a couple things, only one kind of small step that you can skip. But again, you don't have to show every in-between calculation. So we found our two solutions, or we got two solutions at the end. So therefore, there are x-intercepts at negative 0.45 and negative 2.22. So we have two solutions, two x-intercepts for this. Now, if we're trying to find the vertex from this standard form, we talked about in the last one, we would go through and we would complete the square, which we looked at in a previous lesson, and then that would convert it to the vertex form, where we would then find our vertex, right, or a maximum or minimum. Now, if we have the quadratic formula, we can find our vertex as well by kind of combining it with the midpoint formula, because if I know my two x-intercepts, I know the vertex is going to be in the middle of that. Now, kind of to shortcut it, the x value of the vertex from standard form can be found by doing x minus b divided by 2a. So this is also our axis of symmetry, right? The x value of our vertex is our axis of symmetry. Axis of symmetry, or the x value of the vertex. So what we're going to do next, we want to find the x-intercepts the vertex and create a rough sketch of this parabola, which is negative 4x squared plus 2x plus 7. So I'm going to write down my a, my b, and my c, because if I want to find my x-intercepts or my roots, I'm going to need to use the quadratic formula. I could try to factor, but again, because in this lesson we're talking about the quadratic formula, we want to practice that a bit more. So I have my a value of negative 4. This is the first time we're introducing negatives. So if there is a negative or a minus in our equation, we have to make sure we include it for the appropriate value. So a equals negative 4, b equals 2, and c equals 7. So I'm going to take my quadratic formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. I'm going to plug in my values now, so I'm going to have negative 2. Now, since we're dealing with negatives for the first time, if the b value happened to be negative, I would still have to include a double negative in this equation. So just because this negative is here already does not mean that if b was also negative, I don't need to include it. What I mean by that is, let's say just hypothetically, if this was a negative 2x, I would have to have negative 2. Right? In our case, though, it's not a negative, so I don't have to worry about that. I can just do minus 2, but just something to keep in mind when you practice. So negative 2 plus or minus the square root of 2 squared minus 4 times negative 4 times 7, all divided by 2 times negative 4. I can go through and simplify this. Negative 2 plus or minus the square root of 4 minus 4 times negative 4 times 7, or negative 112 divided by negative 8. Now, because it's 4 minus a negative, right, we still need to include that second negative. We can't forget about it. It's the same thing as saying negative 2 plus or minus the square root of 4 plus 112, or the square root of 16 or 116 divided by negative 8. And have x equals negative 2 plus or minus 10.77 divided by negative 8. I'm going to split my equation up into two parts. X is equal to negative 2 plus 10.77 divided by negative 8. And x is equal to negative 2 minus 10.77 divided by negative 8. And from there we get two answers. We get negative 1.09 and we get positive 1.59. So those are my two x-intercepts. So if I'm going back and sketching this, right, I know I'm going to have two x-intercepts at negative at 1.59 and 0, and negative 1.09 and 0. I know it's going to be opening down because of the a value. Now I just need to find my vertex. Right? I could find the x value in between, right, to find those two, find the middle value. X, or I could use the formula, which is b minus, or b divided by, negative b. If I go back up to my formula, negative b divided by 2a. So I have negative 2 divided by 2 times -4, or -2 over -8, or 1 over 4. Now that I have my x value, I can plug that back into my equation to find the y. So y equals, I'm going to use the same equation, -4 times 1 over 4 squared plus 2 times 1 over 4 plus 7. If I enter all of that into my calculator, I end up with 7.25. So that means my vertex is at 0.25 and 7.25. The 0.25 just comes from this fraction, 1/4. So my vertex is 0.25, 7.25. I've already found my x-intercepts from the quadratic equation. Yeah. So again, right, the main idea from this is just if I'm trying to find my roots or my x-intercepts or the solution to this quadratic equation, and I can't factor it, I can use what we now know as the quadratic formula to basically find our x-intercepts regardless of whether it's factorable or not. Just keeping in mind, we can have 0, 1, or 2 possible solutions, kind of like what we saw back up here, right? We could have 0, 1, or 2 x-intercepts. So same idea when we're going through and solving that quadratic formula.